Hello students, today's topics are triple integral as the limit of a sum, calculation of triple integral, and then finding volume by triple integration. Also lastly we shall see the definition of line integral. So first we see triple integral as the limit of a sum. Definition is similar to double integral. Let f of xyz be a bounded function of three variables x, y, z defined at each point in a bounded three-dimensional region capital E subset of R cube, and let this region E is divided into n sub-regions E1, E2, E3, En with respective volumes delta V1, delta V2, delta V3, delta Vn, and let first bracket xr comma yr comma zr be any point in er, that is in rth subregion for all r equal to 1 to 3 n. That is, we have taken the point x1 y1 z1 from e1, x2 y2 z2 from e2, etc. Then the limit of the sum summation f of xr yr zr function value at xr yr zr into delta vr volume of the rth subregion. Limit of this sum as n tends to infinity, number of subdivisions tends to infinity, and simultaneously largest of delta Vr tends to 0. Volume of the largest subregion tends to 0. So volume of every subregion tends to 0, very small every subregion, and limit of this sum, if it exists, is called the triple integral of the function f over the region E and is denoted by this symbol. Triple integral symbol, function f x y z dv over the region E, or this dv is actually can be written as dx dy dz, elementary volume element. So this is definition of triple integral as the limit of a sum. Thus triple integral of the function f x y z over the region E is given by this limit as n tends to infinity, of course simultaneously largest of delta Vr tends to 0. The expression is summation f of x r y r z r into delta Vr, r from 1 to n. Now in particular, if this function f of x y z, this bracket is not there, f x y z is equal to 1 for all points in E, then the triple integral becomes limit as n tends to infinity summation delta Vr, 1 into delta Vr, where of course largest of delta Vr tends to 0. So it is sum of volumes of each subregion. Okay, so it is actually total volume of the region E. So triple integral gives volume when the function is 1 constant. Now if we consider f of xyz as density, mass per unit volume at the point xyz, then the triple integral, this triple integral f xyz dx dy dz over the region E gives the total mass of the region E. So this may be taken as physical interpretation of the triple integral. Now how to calculate triple integral in a special case. Calculation of triple integral. If f of xyz, the function f of xyz is a continuous function in the region E bounded by continuous surfaces z equal to phi 1 xy, z equal to phi 2 xy, y equal to psi 1 x, y equal to psi 2 x, and planes x equal to a and x equal to b. The region is bounded by 4 surfaces, 2 plane surfaces, where of course a less than b, phi 1 xy less than or equal to phi 2 xy, psi 1 x less than or equal to psi 2 x. That means z equal to phi 2 xy is upper surface, z equal to phi 1 xy is lower surface, phi 1 xy less than or equal to phi 2 xy, upper surface, lower surface. Then y equal to psi 1 x, y equal to psi 2 x, psi 1 x less than or equal to psi 2 x means back surface, front surface, not visible here in the figure, back and front, and then left and right, x equal to a, x equal to b, x equal to a is a plane parallel to yz plane, x equal to b is a plane parallel to yz plane, left face, right face. So if the region is bounded by this type of surfaces, then we can calculate the triple integral like this, repeated integral. First we integrate with respect to z from phi 1 xy to phi 2 xy along the vertical strip. This is a vertical strip, z equal to phi 1 xy to z equal to phi 2 xy, arbitrary vertical strip, thin strip. With respect to z we integrate, here x and y are both constant along this strip, as if partial integral with respect to z integrated. Then we integrate from y equal to psi 1 x to psi 2 x, means the strip is moved parallel to YZ plane from back to front. Back to front, a sheet will be generated. A sheet will be generated like that. If we move this strip from back to front, psi 1 x to psi 2 x, sheet will be generated. So integration along this street. And then if we move this sheet from x equal to a to x equal to b, from left to right, that is integration from x equal to a to x equal to b, finally with respect to x, then the whole region is covered. So thus the triple integration is calculated as repeated integral. Also we can integrate like this. First we integrate with respect to z from z equal to phi 1 xy to phi 2 xy along the vertical strip, and then we give here double integral symbol. Okay, after integrating with respect to z, double integral with respect to x and y over the region D. What is D? D is the projection of E on the xy plane, shadow of the region on the xy plane, D. So single integral, double integral, or three single integrals, maintaining proper order. So this is the process for calculating triple integral for this special type of region. Okay. Now sometimes we may change, or we need to change the variables in triple integral, similar to double integral formula. Just we are writing the formula, change a variable in triple integral. Triple integration of the function f x y z over the region E with respect to x, y and z, of course, is given by triple integration of the function f of f, same function but x, y, z are replaced by phi 1 ubw, phi 2 ubw, phi 3 ubw over the region E1, and dx dy dz becomes Jacobian of the transformation del x, y, z by del ubw with, of course, modulus into du dv dw, where E1 is the region in ubw space which correspond to E in xyz space under the transformation x equal to phi 1 ubw, y equal to phi 2 ubw, z equal to phi 3 ubw. Okay, so this is the formula for change of variables. Now two important transformations. Let us see two important transformations. Very often we may use them for calculating triple integral, especially for spherical region or cylindrical region. Okay, first one, Cartesian to spherical polar coordinates. If x, y, z and r theta phi are Cartesian and spherical polar coordinates of the same point, then the transformation equations are like that: x equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta. So in this case, the Jacobian of this transformation del x, y, z by del r theta phi, if we calculate, we shall get this r square sin theta. So that dx dy dz will become r square sin theta dr d theta d phi. We shall use this. Now justification of this relation, let us see. If P is any point with coordinates x, y, z, Cartesian coordinates, then what are x, y, z we know still. Say Pn is dropped perpendicular on xy plane, On is joint, Nm is perpendicular on x-axis. Then OM is x, all of we know, Mn is y, and Np is z. This is Cartesian coordinates x, y, z. Now what are spherical polar coordinates? This ONP joint, this OP is equal to r, say. This is r, measured rule is positive, and this OP makes an angle theta with z axis, positive direction of z axis, say this is theta. Okay, and the plane OPN, through OPN and we can draw a plane. The plane OPN makes an angle phi with zx plane here. So this angle phi, this is phi. So this r theta phi locates the point P. If we know r theta phi, we can locate the point P. So this r theta phi are called spherical polar coordinates. R theta phi, spherical polar coordinates of the point P. Okay, now what is the relation between them? Here Nm is perpendicular on x-axis. So OMN is a right angle triangle. OMN is a right angle triangle. OM is x, Mn is y. Okay, and Pn is perpendicular on xy plane. So actually angle ONP is 90 degree. See the figure ONP. So ONP is a right angle triangle. Okay, now this is theta, so that is also theta. So here it is theta, and Pn is here adjacent to theta, On is opposite. So from this right angle triangle we get Pn equal to r cos theta, On equal to r sin theta. Okay, and then from this triangle we get, this is the angle phi, here it is phi, so phi is adjacent to x. So x equal to On cos phi means On equal to, and Mn means y equal to On sin phi opposite. So what we have written, z equal to Pn. Pn is OP cos theta from this triangle. OP cos theta means R cos theta. So z is R cos theta. Then ON already we have seen, ON is R sin theta. Therefore from triangle OMN, x equal to OM equal to ON cos phi. From this line we get OM equal to ON cos phi, and ON already we have got R sin theta. So it is R sin theta cos phi. Similarly, y is mn is ON sin phi. From this, ON sin phi, ON is R sin theta, so y is R sin theta sin phi. Therefore, we have proved x equal to R sin theta cos phi, y equal to R sin theta sin phi, z equal to R cos theta. We have to remember. This is the transformation equations from Cartesian to spherical polar coordinates. Now, if we want to describe a spherical region with center, origin and radius a, then what will be the ranges of values of R theta phi? See. Okay, this is z-axis and its opposite direction is here z dash, opposite direction. Now for a particular position of the point P, OP, if we rotate OP from theta equal to 0 to theta equal to pi, theta equal to 0 to theta equal to pi about origin O, then we get a semicircular disc. Theta equal to 0 to pi, theta equal to 0 to pi, semicircular disc. Okay, now if we revolve this disc about z-axis through 360 degree, we shall get a spherical region. Spherical region is described. So what is this disc? This disc, semicircular disc, makes, and the plane of the disc makes an angle phi with z-axis plane. So if phi varies from 0 to 2 pi, the rotation will be 360. So that's why limits for phi 0 to 2 pi. And for the whole sphere, this is R. R will vary from 0 to A. 0 to A. So that's why R 0 to A, theta 0 to pi and phi 0 to 2 pi gives us the whole spherical region. Okay. And similarly, it can be described by this also, R 0 to A, theta 0 to 2 pi and phi 0 to pi. In that case, what we see actually, phi 0 to pi, if we take, then it will give a semicircular disc like that, phi 0 to pi. And then if this semicircular disc is rotated about x-axis to 360, that is theta 0 to 2 pi, then spherical region will be described. So this way also we can describe the spherical region. And if we want the positive octant of the spherical region only, then the ranges of values of R theta phi are R from 0 to A, theta 0 to pi by 2, phi 0 to pi by 2. In that case, theta will be 0 to pi by 2, 0 to pi by 2 from z-axis to x-axis, and then phi will be from 0 to pi by 2. So this piece in the positive octants, piece of the sphere, octant of the sphere in the positive octant will be described if R 0 to A, theta 0 to pi by 2, phi 0 to pi by 2. Now, second transformation, Cartesian to spherical, cylindrical polar coordinates. Cylindrical. If x, y, z and r theta z are Cartesian and cylindrical polar coordinates of the same point, then x equal to r cos theta, y equal to r sin theta, z equal to z. In cylindrical polar coordinates, nothing but polar coordinates in plane, r cos theta, r sin theta for x and y, and z remains z. So if the region is cylindrical, we shall apply this transformation. And here, of course, if we calculate the Jacobian del x, y, z by del r theta z, it will be r. So that dx dy dz will become r dr d theta dz. Okay. Now let us see some examples. First example here. Compute the triple integral. This triple integral dx dy dz divided by x plus y plus z plus 1 whole thing cube. Function is, integrand is 1 by x plus y plus z plus 1 whole thing cube. Region is capital E, and it is bounded by the coordinate planes x equal to 0, y equal to 0, z equal to 0, and the plane x plus y plus z equal to 1. Means x0 means yz plane, y0 means zx plane, z0 means xy plane, and this is an oblique plane cutting x-axis, y-axis, z-axis at unit distance from origin. So how to integrate this function over this region? So limits of x, y, z we have to see first. So for that, this is the region, 3 coordinate planes and the oblique plane. The shape is like a pyramid. It is called tetrahedron. Pyramid region, pyramid type region, tetrahedron. So first we consider a strip parallel to z-axis from z equal to 0 to z equal to 1 minus x minus y. See this red strip. The strip vertical parallel to z-axis starts from xy plane, z equal to 0, goes up to what? Oblique plane. There is oblique plane. Oblique plane is x plus y plus z equal to 1. So here z equal to 1 minus x minus y. So that's why z varies from 0 to 1 minus x minus y. Now, then this strip, red strip, is translated parallel to y-axis from y equal to 0 from zx plane to this point y equal to 1 minus x. Actually, when x plus y plus z meets xy plane, we get z0. So this becomes a line that is x plus y equal to 1. So here y equal to 1 minus x. Means if we move this strip from y equal to 0 to y equal to 1 minus x, see a plane sheet will be generated. Means integration over this plane sheet first taken second time. First time 0 to z, 0 to 1 minus x minus y, and then this strip is moved from y equal to 0 to y equal to 1 minus x. After that, if this plane sheet is moved from x equal to 0 to x equal to 1, then the whole tetrahedron region is covered. So this is the process. What is written here? First we consider a strip parallel to z-axis from z equal to 0 to z equal to 1 minus x minus y, and then it is translated from y equal to 0 to y equal to 1 minus x. This plane sheet will be generated, and then a plane sheet is generated which is then translated from x equal to 0 to x equal to 1, and thus the whole region is described. So the integral, triple integral over the region E of this function is given by, first we integrate with respect to z. Z equal to 0 to 1 minus x minus y, function is x plus y plus z plus 1 to the power minus 3. Then with respect to y from 0 to 1 minus x. Then finally with respect to x from x equal to 0 to 1. Okay, so integration of x plus y plus z plus 1 to the power minus 3, where x, y, 1 are all constant. So it is to the power minus 3 plus 2 plus 1 by minus 3 plus 1, means minus 2 by minus 2. Okay, and limits for z, if we put z equal to 1 minus x minus y, we shall get only 2, minus when z is 0, x plus y plus 1 to the power minus 2. Okay, now if we integrate with respect to y, 2 to the power minus 2 is 1 by 4. So it is 1 dy, means only y, plus x plus y plus z 1 to the power minus 2. If we integrate, it will be minus 2 plus 1 by minus 2 plus 1, means another minus 1 will come. That's why this minus becomes plus. It is x plus y plus 1 to the power minus 1. Limits for y 0 to 1 minus x. If we put y 1 minus x here also 1 minus x, means it will be 2, and then y0 means x plus 1. Finally we simplify, 1 by 2 and 1 by 4, 3 by 4, x by 4, here is x plus 1 to the power minus 1 means 1 by x plus 1. So if we integrate, then 3 by 4x, x square by 2 means it will be 8, then it is log 1 plus x. Now upper limit 1, lower limit 0, if we put, we are getting 3 by 8 minus 1 by 8 log 2, and when x is 0, this is 0, this is 0, this is log 1. Log 1 is also 0. So finally we get half log 2 minus 5 by 16. Minus minus plus, so it will be half log 2, and 3 by 4 means 6 by 8 we can consider. 6 by 8 minus 1 by 8, 5 by 8, and there is a 2, 16, so minus 5 by 16. So this is the value of the triple integral. So next example, evaluate triple integral of the function 2x minus y minus z over the region E, and it is given by 0 less than or equal to s less than or equal to 1, 0 less than or equal to y less than or equal to x square, 0 less than or equal to z less than or equal to x plus y. All the limits for x, y, z are clearly given. So here also we see that limits for z are variable functions of x and y. More number variable here involved. So we have to integrate with respect to z first. So integration with respect to z first, z equal to 0 to x plus y. Then with respect to y 0 to x square, and finally with respect to x 0 to 1 constant. So twice x minus y minus z, integration with respect to z, there is a minus sign, so 1 minus will be there, and twice x minus y is constant, so it is as if minus z to the power 1 like that. So it is to the power 1 plus 1 means 2 divided by 2, normal integration. Now if we put z equal to x plus y, we get x minus 2y. If we put z to x minus y, so minus half taken out, x minus 2y square minus 2x minus y square. Now if we simplify this, we get, break the square, we get 3y square minus 3x square means 3 into y square minus x square, dy dx, 3 taken out, minus 3 by 2, y square integration y cube by 3 with respect to y, x square is constant, so it is just x square y. Now if we put y is x square, we get x to the power 6 by 3, x to the power 4. Okay, again if we integrate, x to the power 7 by 7 means it will be 21, minus x to the power 5 by 5, 0 to 1. So finally it is 1 by 21 minus 1 by 5, upper limit 1, lower limit 0. So simplifying, we have got 8 by 35. Next example, find the volume of the tetrahedron formed by the coordinate planes and the plane x by a plus y by b plus z by c equal to 1, where abc are all positive. So now we have to find volume using triple integral of this tetrahedron. It is tetrahedron, pyramid like body. So xy plane, yz plane, zx plane, 3 boundaries, another boundary, this oblique plane. So this time directly we can find, but if we change the variables it will be better. Let x by a equal to u means x equal to au, y by b equal to b means y equal to bb, z by c equal to w means z equal to cw, so that this divided by a, b, c gone. So number 1 becomes u plus b plus w equal to 1, simpler plane. This is a plane in UV space, making intercepts 1 unit each on the new axis. This was original tetrahedron, now this is the new tetrahedron, similar shape, only intercepts become same. Okay, now we have to check the Jacobian, del xyz by del ubw. So del xyz by del ubw definition is this: functional determinant. This is del x by del u, del x by del b, del x by del w. Means first row partial derivatives of x with respect to ubw. Second row partial derivatives of y with respect to ubw. Third row partial derivatives of z with respect to ubw. And del x by del u is only a, del x by del b 0, del x by del w 0, because b, w are not there. Similarly, second row 0 b c, third row 0 0 c. So it is just ABC. So that after change of variables, dx dy dz shall become ABC into du dv dw. ABC are positive. Now let E be the region bounded by the tetrahedron in xyz space E, and E1 be the corresponding region in UBW space, which is also a tetrahedron formed by the new coordinate planes U plane, V plane, W plane, like that, and the plane number 2. This is plane number 2, simpler plane. Therefore, required volume of the given tetrahedron is equal to triple integral over E of the function 1, just 1. When function is 1 dx dy dz, then it becomes volume, we know. So first we have to integrate with respect to z, because z limits of z here, after changing the variable it will be w. Okay, so after changing the variable, dx dy dz becomes abc du dv dw. We have changed the variables and the integration becomes over the region E1. So abc taken common constant. Now limits of ubw, see in the figure, w varies from ub space to the oblique plane, that is ub plane here is w0. So w varies from ub plane, hence here w0 to oblique plane u plus b plus w1 means w equal to 1 minus u minus w. So and then that is limits for w, and then this strip is more parallel to v axis from v equal to 0 to v equal to 1 minus u. When w is 0, we get u plus v equal to 1, so v equal to 1 minus u. So limits for b 0 to 1 minus u, and finally limits for u 0 to 1. So first w 0 to 1 minus u minus v strip, and then the strip is moved parallel to v axis, this sheet, and then sheet is moved from u equal to 0 to u equal to 1. Okay, so this is the repeated integrals. Now dw integration 1 dw means just w, upper limit is 1 minus u minus b, other things remaining same. Then we integrate with respect to b, 1 minus u constant, so it will be 1 minus u minus b to square by 2 with a minus sign because coefficient of b is minus 1. Then putting the value of upper limit, that is value of b 1 minus u and 0, so we get here b 1 minus u means 0 minus 0, and when b is 0 it is 1 minus u square by 2, okay, and minus minus plus, that's why here it is plus. And finally it is abc, and 1 minus u square, if we integrate with respect to it will be 1 minus u cubed by 3 with a minus sign, so it is 6, 2 into 3 6. So finally when u is 1 it is 0, when u is 0 it is 1, so minus 1, 0 plus 1 means 1 by 6 abc cubic unit, volume of the tetrahedron. Next example on volume. Find the volume of the region in the first octane, that is positive octane, bounded by the cylinder x square plus z square equal to 1 and the plane x equal to y. X square plus z square equal to 1 is a circle in the xz plane, center origin radius 1, but it is a cylinder in 3 dimension and its axis is y axis. That's why see y axis is given vertically, so it becomes vertical cylinder, y axis, x axis, z axis. Okay. Now let E be the region in the positive octane within the cylinder cut off by the plane y equal to x or x equal to y, as you write, y equal to x or x equal to y is the plane. It is a line in xy plane, but it is a plane in 3 dimension, and it cuts the cylinder obliquely, and we have to find the volume of this portion. So the projection of E on ZX plane is a quadrant. This is the region E, and its projection XY plane is a quadrant of unit circle, because we need only positive octane. So this is unit circle in the first quadrant, and let it be D, denoted by D here. Therefore required volume equal to triple integration 1 dx dy dz, okay, over the region E. So this can be written as single integral and double integral. Here what we see, limits of y are variable, y equal to 0 to y equal to x. Y varies from xz plane along the wall of the vertical cylinder up to the point where the cylinder is cut by the plane y equal to x. So y equal to 0 to y equal to x, so integrated with respect to y first, y equal to 0 to y equal to x, and then we have given the double integral symbol over the region D, where D is the projection of E on xz plane. So it is just integration dy means 1 dy means y, so it is x upper limit minus lower limit, so x dz dx. Now this is just circular region, that's why we go to polar coordinates. Let x equal to r cos theta, z equal to r sin theta, instead of y it is z. Then dz dx becomes r dr d theta, Jacobian of the transformation will be r, and the ranges of values of r and theta will be, say r means radius from 0 to 1, radius is here 1, r equal to 1, and theta will be obviously from 0 to pi by 2, x axis to z axis here. Therefore the required volume is integration 0 to 1 for r, 0 to pi by 2 for theta, and x means r cos theta, dz dx means here r dr d theta. Therefore limits are constant, so we can separately integrate 0 to pi by 2 cos theta d theta and 0 to 1 r square dr. Cos theta integration sin theta, r square integration r cube by 3, sin pi by 2 is 1, sin 0 is 0, r is 1, r is 0, so it is 1 by 3 cubic unit. So this is the volume of the region. Then next example, show that the volume common to the cylinders x square plus y square equal to a square and x square plus z square equal to a square is 16 by 3 a cube cubic unit. Two cylinders, volume common to the cylinders, answer is given. So what are the cylinders? X square plus y square equal to a square, x square plus z square equal to a square, radius same, and for first one axis is z axis, for second one axis is y axis. So both the cylinders are symmetrical about their axis and are of equal radius. So required volume is symmetrical about all the coordinate planes. See in the figure, x square plus y square equal to s square, its axis is z axis. In the middle z axis, cylinder. And second one, x square plus z square equal to s square, y axis in the middle. So we have given y axis here for better understanding, y axis here. Okay, so horizontal cylinder, vertical cylinder, like that. Now the cylinders are the required volume, common portion of the cylinders in all the octants are same. So if we find the volume common to the cylinders in the positive octant, first octant, and multiply it by 8, because there are 8 octants. 3 coordinate planes divide the whole space into 8 compartments called octants. So multiply this volume by 8, we get the total volume common to the cylinders. Therefore, required volume common to the cylinders is 8 into volume in the positive octant common to the cylinders. Now this is 8 into triple integral 1 dx dy dz over the region E, where E is the region common to the cylinders in positive octant, first octant. We have marked it E. Now what will be the limits for x, y, z, like that? So first we see that limits for z equal to 0 to z equal to root over s square minus x square. How? Z in the positive octant, z starts from 0, goes along the vertical wall of the cylinder, first cylinder, and up to what? Where it is cut by the horizontal cylinder. Horizontal cylinder, what is x square plus z square equal to s square. So here z square is s square minus x square, z is root over s square minus x square in the positive octant. That's why you have written z equal to 0 to z equal to root over s square minus x square. It is along the wall of the vertical cylinder, but up to the point where it is cut by the horizontal cylinder. So that's why integration 1 dz, z equal to 0 to root over s square minus x square. So if we integrate, we get just z, upper limit is root over s square minus x square, and then we have given here double integral symbol over the region D. What is D? Where D is the projection of E in the xy plane in the first quadrant. So shadow of this E in the first quadrant, first quadrant of the xy plane. See, the shadow will be this portion, and this portion is given here again. So it is a quadrant of a circle in the xy plane. So that is 8 into double integral over D. Function is root over s square minus x square. Dx dy is the symbol for double integration here in the xy plane. So here we see that the limit for y for this double integral, y from 0 to root over s square minus x square, because the strip starts from x-axis, goes up to the boundary of the circle. Circle is x square plus y square equal to s square in the xy plane. So y equal to root over s square minus x square. Got. And then this strip is moved from x equal to 0 to x equal to a, whole circular region is covered. So that's why see x 0 to a, y 0 to root over s square minus x square. dy dx means we have to integrate with respect to y first, limits of y variable. So root over s square minus x square constant, integration 1 dy will be just y, upper limit is again root over s square minus x square, so and lower limit is 0, so we are getting root over s square minus x square 2 times here multiplied. So finally root over gone. So again integrated with respect to x, s square x cubed by 3, upper limit a, lower limit 0. If we put, we get 16 by 3 a cube cubic unit. So this is the volume common to the cylinders. Okay, and more problems we shall do in the next class. And just here I give the definition of line integral. Let f vector xyz is equal to f1 xyz I cap, f2 xyz j cap, f3 xyz k cap, means capital F1, F2, F3 are components of this vector point function f bar xyz. And this function is continuously differentiable vector function defined at each point of an oriented smooth arc capital C of a curve given by r vector equal to x I cap plus y j cap plus z k cap. R vector is a function of t, scalar variable t, xt I cap plus y t j cap plus z t k cap. This is the equation of the curve, and its one part is C, oriented smooth, where t lies between a and b, while t varying from a to b. When t varies from a to b, the orientation direction is there. We get the arc in a definite way, oriented. And if we vary t from b to a, then of course we shall get the opposite arc. That's why oriented smooth arc written. Then the line integral of this vector function f bar along this arc C is denoted and defined by this symbol, integration over the arc C f vector dot dr vector notation equal to what? Calculated like that, integration a to b f vector dot dr vector by dt into dt. Dr vector is dr vector by dt into dt, and f vector is f1 already here, f1 I cap plus f2 j cap plus f3 k cap, and dr bar by dt will be dx by dt I cap, dy by dt j cap, dz by dt k cap. So if we take dot product, coefficient of ij are multiplied, so we get f1 dx by dt plus f2 dy by dt plus f3 dz by dt. So integration is finally a single integral, normal integral a to b with respect to t. In two dimension, it is given by, symbol is integration over c f vector dot dr vector equal to same notation, integration a to b f vector dot dr by dt into dt is equal to integration a to b f1 dx by dt plus f2 dy by dt. In two dimension, z is not there. So this is the definition. Problems we shall do in the next class. Thank you for today.